Okay, in this video, we're going to talk about some more circle proofs. And yes, I can see your faces without a doubt. I know you're going, oh no, proofs again. Well, these proofs are not that at all. They're just going to use some knowledge that we've talked about with circles and just put together some information that we've learned in our past, as we've done before. But these are pretty straightforward, and a lot of you know what that means when I say that. All right, so number one, it says given AC, line AC is tangent to circle O at A and circle P at C. We need to prove that angle O is congruent to angle P. And what we're going to do is let's mark up what we have. So what we have is we have this line AC, do a little highlighter. That line AC, all right, is tangent to those two circles. Now we have to prove that the two angles, angle O and angle P, are congruent. And immediately, I know a lot of you see those triangles there. All right, and that's big. So what I'm going to do immediately, I'm going to finish marking my triangle, but what I'm going to do immediately is I'm going to mark our favorite. You guys love that one. Okay, vertical angles, we have that there. And then also, what's important is that we know from what we've learned in the past couple days that if we have a tangent line to a radius, that they form right angles. Very important. So I'm going to mark my right angles right here. All right, tangent to the radius, right angles. Now, there are a couple different approaches to this proof. So one is that if I have a line that's perpendicular, which that tangent line is, to two lines, all right, the same line is perpendicular to two lines, well, you know that line CP is parallel to line OA. We learned that in our past. And then you can go at this with alternate interior angles. What I'm going to do just straight up, I'm just going to say if I have two angles in a triangle that are congruent, then the third angle must be congruent. So angle O must be congruent to angle P. I liked what one student did in one of their reviews is they wrote down their thoughts. So I suggest you do the same thing. Write down your thoughts so that you gather those thoughts when you're writing your proof. So let's go at this one. So the first thing I'm going to write, let me see if this is cool. It is that I have AC, line AC tangent to O at A, that's an at, and it's tangent to P at C. And that reason is given. And no, you cannot skip that. All right, very important. All right, now the second thing I'm going to write is that AC, the line AC is perpendicular to line OA, and it's perpendicular to line CP. And that reason is line tangent to the radius forms perpendicular lines. Okay, I should also write that um, angle, I'm going to do a 1 and a 2 just to make it easier. Angle 1 and angle 2 are right angles. And 3, that's definition of perpendicular lines. And then 4, angle 1 is congruent to angle 2. Right angles are congruent. And then 5, I have angle ABC is congruent to angle PBC, and that's vertical angles. Six, angle O is congruent to angle P, and again, that's two angles congruent in a triangle. Therefore, third angle must be congruent. All right, like I said, not too bad on that one. All right, let's go to our next one. All right, it says in circle O, diameter AC is extended to D. All right, that's cool. Such that AD is perpendicular to DF. All right, it's already given us our right angle. It says prove that AF times EC equals AC times FD. Okay, so if I'm thinking thoughts again, all right, so I have to be thinking similar triangles. All right, similar triangles, because that's going to put them in proportion. Okay, so the first thing I'm going to do is I'm going to highlight what do I need to prove, which triangles do I need to prove are similar. So it says AF, and then I'm going to use another highlighter, EC, and then I'm going to have AC, and FD. All right, so I need to prove that those two triangles are similar. All right, that's AFD and ACE. I have to prove that those two are similar. All right, in order to prove similarity, I'm going to approach this with angle, angle. Now, what do I see? Well, I have angle E up here. All right, that's an inscribed angle, and that inscribed angle, all right, is cutting this circle, or the arcs of that inscribed angle. Very important. Is the semicircle. That's 180 degrees. So I know that angle E has to be a right angle. All right, very important. So I have I have one angle, sorry. I have angle E is a right angle. I have angle D is a right angle that was given to me. And I also should see that angle A is shared by both. So there's where I'm going to get my angle, angle. Those are my thoughts. All right, so let's write it up. 1, I have diameter AC is extended to D. Such that AD is perpendicular to DF. And that's given. All right, 2. I'm going right for it. I have angle A. I should write angle. Angle A, sorry about that, is congruent to angle A. And we know that's reflexive property. All right, number 3. I have angle FDA is a right angle. And that reason is perpendicular lines form right angles. Number 4, I have angle AEC is a right angle. And that reason is inscribed angles in a semicircle is a right angle. All right, and I should state that, and I will, that angle FDA is congruent to angle AEC. And that reason right angles are congruent. Are congruent. Cool. And then my last, so I have the two angles. I have two stating right angles are congruent. I have 5 stating that 2 angles are congruent of the triangles. I have triangle ACE is similar to triangle BFA. And the reason is angle, angle. And then 7, I have AF times EC equals AC times FD. And I'm just going to write sides are similar when the triangles our sides are in proportion when the triangles are similar. All right, cool. So what I want you to do, obviously, is some key ideas and the check your understanding proof, which is pretty cool. It's the last one. All right, so thank you, and go Cats.